Hey, I am here to present our new innovative project, Flood-Proof Airbag Safety System for Automobiles. In the recent years 2019 to 20, Kerala faced a situation of heavy floods. Almost 350 vehicle dealerships were affected by the large-scale flooding, and 17,000 cars are estimated to have been damaged in floods. The automobile industry estimates that inventory worth 1,000 crore has been damaged. Typically, insured losses are about 5 to 6% of the economic losses. Costs are likely to be recovered partially or fully, given that they are insured, but the process may be time-consuming. The main purpose of this project is to save automobile during the flood, and as a result prevent all the financial losses occurred from vehicular damages due to drowning. So we introduce our innovative project, Flood-Proof Safety Airbag System for Automobiles. Our main objectives: to minimize the damages to the automotive bodies caused by the flooded water, which contains many contaminants and salt, avoid the drowning of vehicles, and save the life of the passenger. Our system, which can be installed on the chassis of the car, and also provided a thruster mechanism for the proper stability of the vehicle in the water. Methodology behind our system is buoyancy. Buoyant force acts as vertically upward through the centroid of the displaced volume, discovered by Archimedes. What is buoyancy? Buoyancy is an upward force exerted by a fluid that opposes the weight of a partially or fully immersed object. In a column of fluid, pressure increases with depth as a result of the weight of the overlying fluid. The pressure difference results in a net upward force on the object, whose average density is greater than that of the fluid in which it is submerged tends to sink. If the object is less dense than the liquid, the force can keep the object afloat. Schematic diagram of miniature design. Main components used in miniature model are 12-volt DC battery, open/close valve, DC motor thrusters, airbag, 12-volt DC compressor, solenoid valve and other fittings. Total project cost estimation of the miniature system is all around 10,300 rupees. We just expected outcome target customers. While considering Ernakulam district there is more than 30,000 cars, taking 5% of it, therefore 1,500 car owners. So if we are selling each of our product at the rate of 20,000 per unit, so in terms of INR potential market size, estimated is about 3 to 5 crores. A fabrication of system. The system consider as two sections, primary and secondary. The primary system consists of the water sensor, airbag, solenoid valve and storage tank. The secondary system consists of a compressor, pressure gauge, pressure switch and storage tank. The storage tank is the common component and it is the component that links both the primary and secondary systems. We provided a thruster mechanism for the proper stability of the vehicle body. By using a 12-volt DC motor, which is placed on all corners of the body. 2 motors will be fixed in front and 2 in the back, so that it will oppose the flow of water during a flood having some flow speed. The motors will be connected to a battery with the help of a circuit unit. It can be easily controlled by manual or automatic system. Working. The driver force behind the flood-proof safety airbag system is the Archimedes principle, which is utilized to lift the car by supplying air and inflating an airbag, which results in the formation of a floating body that helps to maintain the car body to float above the water level. In the primary system, the water sensor, which is placed 45 centimeters above ground level, to initiate the contact with water. On receiving the signal to solenoid valve by sensor, which allows the passage of air from the storage tank to the airbag through the inlet and outlet of the solenoid valve, respectively, causing the gradual inflation of the airbag. Once the air inside the airbag reaches the maximum pressure, which cut off the supply of air to the airbag by pressure switch. In the secondary system, the compressor is the supplier of air and supplies air into the storage tank, which stores this air. The storage tank then supplies the air into the airbag via the process of the primary system, whenever it is required. However, the supply of the air into the storage tank by the compressor is controlled by the pressure switch, with the help of a pressure gauge. When the pressure inside the tank reaches the maximum pressure level, the pressure switch gets activated and the compressor is shut down, and the pressure switch once again starts the compressor to refill the storage tank. This process takes place continuously to always maintain the required air pressure inside the cylinder, providing thrusters to enable the system to be able to control and the movement of the floating body in water, under the condition the system is activated and in effect. The thrusters get activated and helps the car to remain at the place that it was parked. Industrial application. The flood-proof safety airbag system will have an indirect effect on automobile industries. This system can be used as an add-on feature by automobile manufacturers. The system can also be sold as an aftermarket product, which will make the product available to all customers. Future scope. By using our system, automobiles could be saved from completely drowning during floods. Could be modified to be used as a means of transport during floods or in water bodies. It is an eco-friendly system. During accident situations where a car falls into a river or lake, this system will activate and prevents the car and passengers from drowning. Result. We consider the overall weight of miniature is around 60 kilograms according to the buoyancy equation to calculate the miniature buoyancy, and we scale into the prototype value. So we use buoyancy equation to calculate the buoyant force of the system. These calculations are used to evaluate the required quantities and other properties of airbag. For actual case, we avoid the compressor in automobile to reduce the overall weight of body and better efficiency. Instead, we install a compressed air tank to store the air as per required. An external or stationary compressor is used to refill the air tank. The buoyant force required for the vehicle is around 9,807 Newton obtained by buoyancy equation, and the amount of water displaced is about 1,000 kilograms. So the volume of air inside the airbag required for making the vehicle to float will be 1,000 liters. Conclusion. The miniature car body was scaled-down model of actual car. It has proportional dimensions and weight to determine the factors such as the required amount of air volume, size of the airbag and air tank to manufacture the actual working of flood-proof safety airbag system that can be employed to full-size cars. Thank you.